What we have seen so far in the multiple integration, whenever we have given the rectangular region, then how do we write the limit for dx dy? So inner limit of x, outer limit of y. For dy dx, inner limit of y, outer limit of x. Then we have seen, in place of the rectangular region, suppose you have given any general region R, then how do we write the limit in the case of dx dy as well as in the case of dy dx? So now at this stage we are able to evaluate any kind of double integration on general region R. So let us start with this exercise. Exercise is evaluate double integral over R x plus y dA, where R is the region bounded by the lines. 4 lines we have given: x equal to 0, x equal to 2, y equal to x, and y is equal to x plus 2. So what is our first task always? Our first task is to draw the region. First line x equal to 0. You know that line x equal to 0 is nothing but the y-axis. So let us draw the y-axis first. The equation of this line is x is equal to 0. Next we have given another line x is equal to 2, which is again the parallel line to the y-axis. So suppose this is x equal to 2. Whenever we are drawing the region, we always mention the intersection points. So when x is equal to 2, y is equal to 0 here. Then the third line is y equal to x line. What is y equal to x line? Is passing from the origin. So this is the line passing from origin and the point 1 1. So this is the line y is equal to x, the intersection points. This is the intersection point when x is equal to 2, y is equal to 2. This is the point origin passing from the line passing from the origin 0 0. Now we are going to draw the line y is equal to x plus 2. Which line is this? We should have 2 points from which the line is passing. So when x is equal to 0, what is y? Y is equal to 2. Right. When y is equal to 0, what is x? So when y is equal to 0, 0 is equal to x plus 2, and so the value of x is equal to minus 2. So this is minus 2 comma 0. So the line y is equal to x plus 2 is passing from 2 points 0 2 and minus 2 comma 0. So let us mention these 2 points first on the region. Say this is the point 0 comma 2 when x is 0, y is equal to 2, and say this is the point when x is equal to minus 2. Equation of this line is y is equal to x plus 2. So the first task is over. We need to mention all the curves which has been given. Right. Now again I repeat, which are the curves? The first curve x is equal to 0, the another curve x is equal to 2, the line y is equal to x, and the line y is equal to x plus 2. Right. Now the question is, what is our region? The region is bounded by these 4 lines. See, x equal to 0, to y equal to x, to x equal to 2, and y is equal to x plus 2. So which portion is coming? This is the portion. This is our region R. Right. Now once the region R is fixed, then we are able to write the limits. So now let us start the integral. How do we evaluate the integral? Double integration over R x plus y dA is equal to double integration over r x plus y, then what? So here you have to be careful. dA is what? dA is divided into two parts. We have two cases here. You can mention dA as either dy dx or dx dy. So first of all I am writing this is equal to dy dx. So suppose this is dy dx. Double integration over r x plus y dA, which is equal to double integration over r x plus y dx dy. In the examination you have to work with only one case, either the case dy dx or the case dx dy. But which case will be helpful to us more, dy dx or dx dy? That we need to understand, and for that the observation of region is important, and that is what our purpose for this exercise. So let us start to write first for dy dx. How do we write the limit of y? Y is the inner limit and x is the outer limit, right? So for y, how do we write the limit? We are writing y in this way. So we draw the vertical line, right? How do we draw the vertical line? The line which moves from bottomward to upward direction, right? So I am drawing the line here. So we are entering in this curve from this line. This is our entry in the region, right? So I am writing here, this is our entry, y is equal to x. Now my journey is continue inside the region, and then I get out from the region. So that is the exit. What is the exit? Exit is this curve, y is equal to x plus 2. So we enter from y equal to x line, we continue our journey inside the region, and we exit from the region, exit in the region from this curve, y is equal to x plus 2, right? So my entry will be the lower limit, y equal to x, and exit will be the upper limit, y is equal to x plus 2. Clear? Now we have to write x limit, which is outer limit, always constant. Now how do you write the constant outer limit? We observe the region, we check that how much portion of the x-axis is covered by the region. So this is the portion, this is the only portion covered by the x-axis. So most left hand point is this, which becomes the lower limit, and this right hand side end point is becomes the upper limit. So this point is x equal to 0, this point is x equal to 2. So my lower limit will be x equal to 0, upper limit will be x equal to 2, right? Okay, so this is how we are writing the limit. Once the limit has been written, we are able to solve the integral. So let us go fast again and solve this integral. So this is equal to integration x is equal to 0 to 2. Next, what we have to do? We have to integrate this integral with respect to y. When we integrate with respect to y, x is constant. So x is constant, then remain quantity is 1, which has integration y, plus now this is y. Y has integration with respect to y is what? Y square divided by 2. Then the limit, lower limit is y equal to x, upper limit is y equal to x plus 2, and dx is remaining. Let us substitute the limit value, x is equal to 0 to 2. What we are substituting, keep in mind, in place of y we are writing x plus 2. So x as it is, in place of y we write x plus 2, plus in place of y we write x plus 2. So x plus 2 whole square divided by 2. Don't make mistake when you are substituting the lower limit. So this is the minus sign for lower limit, and now I am writing everything for the lower limit. In the lower limit, what is y? Y is equal to x. So I write x into x is x square, plus y is equal to x, so x square divided by 2 and whole dx. Once this quantity is clear, let us simplify this quantity. So this is equal to integration x is equal to 0 to 2 x square plus 2x plus this is x square plus 4x plus 4 divided by 2. Hope this is clear. X plus 2 whole square is what? A plus b whole square, s square plus 2ab plus b square. This is minus x square and minus x square by 2 whole dx. This is just simple simplification. You can simplify this by yourself. So this is x square minus x square cancel out, minus x square by 2, this x square by 2 cancel out, right? So again the remaining quantity, see, keep in mind this is 4x plus 4 divided by 2. So this is integration x equal to 0 to 2. This is 2x, 4x divided by 2 is 2x, so 2x plus 2x is 4x and plus 4 divided by 2 is, so still we have additional 2, 4x plus 2 dx. Now the integration of this is, now this is simple integration. What is the integration of x? X square by 2, right? So 4x square by 2, let me write direct, which is 2x square. What is the integration of 2 with respect to x? Which is 2x from x is equal to 0 to x is equal to 2. Now substitute the limits. X equal to 2, so 2 square is 4, 4 into 2 is 8. So this is 8 plus 2 into 2 is 4, and so the final answer is 12. This is the end of exercise. I repeat the example again. We have given dA. We have chosen that I am writing dA by dy dx. So first I have to write the limit of y, then I have to write limit of x, right? How we are writing the limit of y? We draw the lines from downward to upward direction. I choose the curve from where we are entering into the region. We choose the curve from where we exit from the region, and then we write x and y, right? Okay, now this is the situation when dx dy, because that is also the case. So let us discuss how we are writing the limit for this one, dx dy. To write the limit for dx dy, what we have to do? Inner limit of x and outer limit of y, that you know very well, right? So we are writing x in this way, so we draw the horizontal line. How we draw the horizontal line? We move from left side to the right hand side. Okay, so I draw the horizontal line in such a way that which intersect our region. We are entering our region. So from which part we are entering our region? We are entering in the region from this curve. What is the equation of this curve? Y is equal to x plus 2. And then we continue our journey and we exit from this curve. Right, which curve? We are exiting from this curve. So we continue our journey and we exit from the curve x is equal to 2. So up to this is clear, right? That we entered from this side and exit. Y equal to x plus 2 to x is equal to 2. But some of you might entered from this curve also. This is the curve because this is the part of our region. So when you are starting from the left hand side, see, when I move my hand from left to right, first we are entering to this portion, this line, right? That this is also part of our region. That means we are entering from this side also. We are not only entering from this side. Clear? So this is also our entry, which is different from y is equal to x plus 2. So this entry is x equal to 0, right? We are moving ahead and we exit from the curve y equal to x. See, this is our exit. Y equal to x is our exit, right? That means what is happening here? See, whenever it was the case dy dx, we had only one entrance, this line, that was the only one entrance, and the exit gate was also one. But here we have two entrance. This is the first entrance, line x equal to 0, the another entrance from this side, and we have two exit. This is the first exit and this is the second exit. Clear? So what we do, as we have seen in the last video, whenever this kind of cases situation occurs, we divide our region into two parts, the region R1 and region R2. So let me divide our region into two parts, right? This is the region R1 and this is the region R2. So now how I am writing this? This is equal to double integration. My region is union of two subregions R1 and R2. So this is R1 x plus y dx dy plus double integral over R2 x plus y dx dy. Clear? So this is equal to double integral. Let us write first for R1. You know R1 is which region? This one, the lower triangle. Let me again draw. This is the region R1, right? In this region we are entering and we exit. So this is my entry, this is my exit. X equal to 0, so x equal to 0 is my entry and y is equal to x is my exit, but I have to write for x, so this is x equal to y is my exit. Clear? Now for this particular portion R1, what I have to write? Outer limit of y, which must be constant, keep in mind, right? How do we write the outer limit of y? We observe the y-axis and how much portion of the y-axis is covered. So from this point to this point, right, which is y is equal to 0 to y is equal to 2. This, see here value of y is 2, so this is y equal to 2 and this is y equal to 0. Clear? Now plus double integration x plus y dx dy, right? How do we write? This is for the second region R2. So how do we write? For R2 we are entering from this side and we exit. So this is my entry, y equal to x plus 2 and x equal to 2 is my exit. I have to write for x. So what is x? X is equal to y minus 2 and here x is equal to 2. So my entry becomes lower limit, exit becomes upper limit. So x is equal to y minus 2 to x is equal to 2. Clear? And then what I have to write? Now outer limit of y, right? How do I write the outer limit? Y. How much portion of this region? See, this is the second part. Our region R2 is this upper triangle, right? So how much portion of the y-axis is covered by this region? As you know, this intersection point, right, has this value y equal to 4 here and here y equal to 2, right? So in this portion the lower point becomes lower limit, top points become the upper limit. So y is equal to 2 to y is equal to 4. Clear? So everything you have, the case dy dx, which is this, how we are writing for the y. The case for dx dy is here, how we are writing from x to y, left side to right side. Only you need to observe how many entrance you have, how many exit gate you have In this case we have only one entrance, one exit. In this case we have two entrance and two exit, right? Okay, now I left to the homework that how you integrate this quantity, this case, right, with respect to x first, then y. This you integrate with respect to x first, then y,